up, guys? On this part of the build, we are going over the C6 Corvette for all of its wiring needs. My brother is over here in the background. What he's doing is building a schematic of the chassis so that we can make a chassis harness and an engine harness to go along with our Link ECU products. Using the PMU, S14 had a lot of little gremlins here and there just because the car had been like rewired 3, 4, 5 times to make it what it is, which it's pretty good now. But we're gonna do this chassis right, full custom harness right off the bat. Joel is one of the owners at Scalar Performance. He's very good with electrical stuff. I'm very good with like suspension stuff, fabrication, things like that. So we go hand in hand really well. So yeah, we'll see what he's doing with the schematic. He can explain it a little bit.
Yeah, so first thing we're gonna do, we're going through the whole chassis, laying out where our fans, pumps, any component, whether it's a load for the PDM or it's a device to control something, we're basically creating a layout, gonna create a string harness through the car. We're making a list in Excel just to kind of get a load of an idea of what our current load is, find out how many PDMs we need, where we're gonna place them in the car, and what other sort of devices we need to put in this.
And in 30 seconds, can you explain what Scalar Performance is?
So we're taking brand new 2023 GR86s, converting them to electric, making them available to be raced in the NASA 2023 season. Super Touring Series, it'll be the first electric race car that you can race with gas cars. It's gonna have 350 horsepower and 350 foot-pounds of torque, so check us out.
On the rest of this video, we're probably gonna be doing something like air jacks and some Firewall block-off plates and a couple things like that. Okay, this is the intro for episode 4, where I'm going to go over in pretty extensive detail how the prototype kit for the suspension is going and all of the cool tricks and benefits and things that I'm doing with it. This is gonna be the first official announcement. This is a kit I've been working on for several months, and you're just getting to see it come to fruition on a car right now. So we're gonna start here at the knuckle. I'm holding everything up with some welding wire just to keep it at relative ride height. What you're looking at is a full custom billet steering knuckle that has the corrected geometry, roll center, and adaptation all made within the bulk of this billet block. What you see here is we can have a look at our built-in kingpin axis angle, which is going to be basically an invisible line going through the upper and lower ball joint. From the front, you can see the built-in caster angle that's going to be going through the upper and lower from a side plane. You can see all of the geometric adaptations really easily on this chassis because the upper and lower are so close to each other. You can see the anti-dive geometry that GM put in from factory, and you can see a lot of cool things about this. Another thing that I did was something different for the adjustable Ackerman. Utilizing the billet block, we have designed basically a bunch of capture pockets that capture these nuts inside of the knuckle. What this allows me to do is bolt on these plates. So these plates are now all modular. This can come off, this can come off, and this can come off. This is the outer tie rod pickup. What's interesting about it is this has a slotted adjustment point, and I have designed these shims. These shims are gonna be how we actually change the Ackerman on this kit. So by sliding it this way, I'm going to reduce or decrease my Ackerman, and then bringing it closer to the knuckle will increase my Ackerman using these shims. So having a shim and clamping it is going to be a much more consistent, sustainable, reliable way of adjusting. This bracket is held on by 4 bolts total, 2 on the side and then 2 going through it this way, so you have 2 points of constraint. It's going to be really solid. Along with the upper and lower, we have 2 bolts going in the top and then 3 going into the knuckle using these capture style slots. Still, you can see the pocket there. Another cool feature is this side over here of the knuckle has basically this open area where it's going to be contacting the lower control arm as a bump stop. That's where I have these come into play. So these are going to be stackable bump stop shims that line up with the 2 holes. So we'll be able to drop these in, decrease the amount of angle that we're getting on the lead wheel. Jack can go to the under head view of this kit going lock to lock, but I'm kind of missing the coolest part about it. The coolest part about this kit is the fact that it uses a different chassis steering rack in the leaf spring pocket of the subframe. Check it out. Inside of the subframe, we have mounted a S13 steering rack. This steering rack is what I've been running on my S14 car for upwards of 7 years. I've actually never had to replace it. The most important thing about these is not overextending them and not overworking them, basically. You have to keep them within their working limits to maintain good seals and not overloading the rack by limiting your angle with the rack. There's a bunch of different ways to keep a steering rack together. We are going to be able to run this steering rack and I don't foresee us having any issues. So putting it in here, we had to modify the subframe a little bit for our fittings and for the knuckle portion of the steering rack. So we had to remove some material here. But otherwise, this plate bolts in with 4 bolts in these corners in less than 30 seconds. So I can drop this steering rack in about 30 seconds. It's held to the plate using these 2 brackets. There's another one just like this one that goes here. And that's basically it. The power steering lines will be run underneath. Our power steering lines going to our pump are going to be nice and short and easy to access with our power steering electric pump going in this front corner of the chassis. This adapter I made. This is really handy because we sell these extensions for a lot of our kits. So this matches the spline of the 240 steering rack, and this goes inside of the factory Corvette steering shaft. What's really cool about the Corvette steering shaft and the steering components, they're extremely high quality. This is a telescopic section of the shaft. It's extremely well engineered. There is 0 play, and it extends like literally over 12 inches. So basically this adapter, I just had to like do some fine grinding on the belt sander to get two nice flats, machine down the diameter a little bit, and it actually goes right inside of, with a little persuasion. Super tight fit. I can pinch it with the pinch pull here. And this steering shaft, without any other modifications, goes right through the factory hole, connects to the steering rack, and from here, I've done some also very interesting things to maintain my factory steering column, and I'll show you that as well. This is the factory pedal box, or what is left of it. It's way lighter than you think. All of these are like aluminum forged parts. And I basically cut the bulk of it off. There was a whole bunch of stuff going on here. This goes in super easy. Slide that in like so. It takes 4 M6 bolts and it bolts right to the front of the Firewall. And then the brake booster, or where the brake booster used to be, is what connects on the other side. I'll show you what we did for that. Be right back. Okay, so this is kind of in pieces, but essentially this is our new booster replacement. This is a bias bar going to 2 master cylinders. These are just placeholders. We're gonna have reservoir ones here. But basically I'm gonna have my front and my rear cylinders mounted to this bias bar brake setup that's gonna connect to the factory location on the Firewall. So I'm gonna have this setup connected to the factory pedals and have all of the benefits of an aftermarket pedal box while maintaining the factory pedals. This will actually become a product. Once we finish it, test it, perfect it, it'll be something that pro level cars can have adapted to their chassis. I wouldn't recommend these because, I mean, removing the booster is going to require a lot more foot pressure, but it's going to be perfect for me and for drifting. So we're going to put this off to the side for now. The next thing I'm going to do is bolt in what I have left of the factory steering column. So this, I actually cut the cable here and welded on a M10 nut. This whole piece actually can unclip and I can take this off, but keeping this on here, I can put an electric ratchet on, as you saw in episode 2, and I can extend this. So that's really handy. I can also change my angle here, but this whole thing used to have a bunch of crap on it. and I machined these down on the lathe, and I reduced the size. I actually got rid of this whole knuckle that has like your tumbler and your locking pin and everything in it. Got rid of all that, stripped it right down to what you have here left, and what's left is like, there's bearings holding this entire shaft in. Everything's really smooth. The U-joints are really high quality. You really couldn't replicate this good of a system with any other product. So for someone as tall as me, being able to, you know, being able to extend and retract the column for, you know, if somebody else does want to test the car or something, they'll be able to do that, and we'll be able to adapt to it. So I'm gonna throw this in real quick. So GM did a great job at making this for a race car. This end, you can see this hole, uses this bolt, and it basically goes onto the end of this steering shaft. So this bolt will go through both, put a nut on the other side. There's nothing more frustrating than if you need to work on your headers or pull the engine or whatever. Generally speaking, the steering shaft needs to come out. With custom columns, it's a pain. With this, a factory column is not going to be a pain. I will be able to work on everything in the engine bay and really quickly remove this. So we'll throw this in, get this on, and we lift this up, line this up with our pedal box. So there's 2 bolts that go there. And then there's 2 bolts that go here. So this is the part that I fabricated and made a reel about. We can put the reel in this video. But basically that's how the steering column attaches to the factory pedal box, the chassis, and then the roll cage. And I took out this entire bulk piece. I might clean this up a little better. Maybe I'll even powder coat this to make it look nice. But yeah, this is really, really good setup so far. Typically speaking, pedal boxes take a lot of time to set up and get perfect. More than happy with just working with the factory stuff because the quality is really good. If you notice the firewall plates, I'll show you how we installed those after this. From here though, basically I'm able to connect any kind of hub style adapter that is sold for a Corvette and adapt it to whatever racing wheel I want. The next steps really are to determine seating position for my ideal head clearance and leg length. Then we're going to be determining where our shifter goes, where the handbrake needs to be, and all of this stuff is just like super fun and exciting to work on. I'm stoked about everything that's going on this car. This video is not over. We still got to do the firewall and we still got to mess around with the air jacks. But yeah, you guys are going to start to see more and more cool stuff as we continue this build series. A lot of stuff in the back end that goes on. Keep watching. I'm going to block all the holes in my firewall using these plates I designed. This will be a product on our website. Each plate is designed to cover a specific hole. You can see they're all different sizes and shapes. Really simple to determine what covers what because the shape is kind of outlined on the firewall of the Corvette. There's holes provided for you to use your choice of fastening method. I am going to use rivets because I don't plan on ever needing to take these apart. You could drill through and put a bolt. To me, that'd be a pain because you'd have to put a nut on both sides. It might vibrate loose. So I'm just going to use rivets. Most of this is never going to come off again. And we did make a plate to cover every single hole. That means the brake booster hole. Let's say you wanted to go to a pedal box. Well, we made a plate to cover that too. So there is a plate for every hole in this firewall. Some of us are going to use all of them. Some of us will only use a few. I'll show you quickly how I drill through and rivet it, and then the rest of the process will be the same. Rivet gun, which you can buy from Milwaukee. Shout out, not sponsored by Milwaukee, but would love to be. This is like 6 years old. Replaced the chuck twice, but the drill itself still works, and the battery designs have just improved, but maintain the same. So I mean, you know, it's good stuff. And also, they are designed to be installed from the inside of the firewall. But of course, this firewall is made of thin fiberglass. Some of the plates you can easily install on either side. I'm gonna do everything from the inside. Dude, chill. Come in from this side. With one example, this plate covers this hole. This hole was originally for like heater core lines or something. Goes right there. Transfer drill these 4 holes. Top rivet that in. Another example, this little plate covers this hole. Another example, this plate, see the shape of this, covers this hole. We are going to need to go through some of these holes with our new wiring harness or with AN lines for oil or water. Once you fasten this on, it's easier to put like a bulkhead through an aluminum plate. So if I wanted to run my AN lines through one of these plates, it's super easy to just drill the hole, perfect fit. The idea is to prevent any fumes, fire, fluids from the engine bay coming into the cockpit. That's why they're thin, that's why they're easy to install, and there's nothing to it. That was a waste. Okay. Other than using rivets and the provided holes would be panel bond, because the Firewall is fiberglass. Typically, you would make these out of steel and you would weld them in or spot weld them in. So you're gonna just panel bond them or rivet them. Those are the only 2 options you have. And that's it. That's the first plate. I'm gonna continue and do the rest of the holes. And then down the road, while I'm building this chassis, I may have to drill through a couple. No big deal.
Dude, what are you weighing?
We're weighing the brackets for the air jacks, and they are 13 pounds for all the brackets, all 4 of them. So you know what the funny thing is? You might have to end up weighing the car overweight anyways to run a certain tire size. So the fact that we're adding these and they are increasing the weight in all the right places, very low center of gravity, wide and in the center between the axles, it's not a bad thing at all. So I'm happy. Our front and rear brackets. This one is the rear. So the rear I can't simulate because I have to break the glue that bonds this to the car. So basically this sits on the frame rail and then this sits against the frame rail for the rear. This goes right on this corner. So it sits flat against the bottom and then we slide it until it meets up with the frame rail. If you're too far this way, it's not level, and if you're too far this way, it pushes it out. So there is only one spot that it goes where it fits absolutely perfect for a nice weld. I'm not going to weld it in here. I'm just going to weld it on this side, and then I'll weld it underneath to the frame rail right there. And this is going to hold our air jack, which is has 2 locking rings, kind of like a coilover. Slide that in, lock it in place, and there's your posts on all 4 corners, just behind and in front of each wheel. The air jacks come with these feet that have handles on them, so when it's fully extended, you've slipped the foot on and then you can let the air pressure out, and it actually will act as a jack stand. So you can take the air pressure off, leave it overnight, leave it up to work on, all sorts of stuff, and it's nice and safe. So the next thing is Kyle's gonna throw on the rivet on all the Firewall plates next. Kyle's gonna do that while I handle some business. That was my exit.
Oh, my bad.